Hello friends, welcome to Achiever Tutorials. Today we are going to do motors. In short, we will understand the theory and explanation of motor. What is a motor? First thing, a motor is a device which converts electrical energy into mechanical energy. In your day-to-day life, you see grinder, you see mixer, you see a fan, you see any mechanical device. When you start the current, when you pass the current, it does some work for you. It rotates, it moves, the escalator, the elevator, they are all motors. Chota motors, you get grinders, the drill machines, everything is a motor. So you pass electricity and the parts of that machine will, what happens is they'll rotate, they'll work for you. So what is a motor? Basically converts electrical energy into mechanical energy. Why will they do? How they do? That is what is important. Just imagine I have a magnet, okay, and if I bring a magnet closer to it, what will happen? They will attract or repel. That is force acting between them. How will we see there is a mechanical force acting? The magnets will move towards or apart. Now let us see magnetic effect of electric current. I told you, whenever electric current is passed through a conductor, through a coil, through a wire, it gets magnetized. Now what I do is, I take a magnet, north-south, and I place a wire in this magnet. As soon as I pass current in this wire, what happens to this wire? It gets magnetized. Now this becomes a magnet. If this is a magnet placed in a magnet, don't you feel there will be attraction or repulsion between the two? And what is moving? This north-south wala horseshoe magnet is fixed. What will move is the wire. If the wire moves, I can place a device near the wire. As soon as the wire, suppose the wire rotates, the coil rotates, the device will also rotate. Drilling machine, grinder, something of that kind. So this is called as a motor. So there are basically two magnets. One is a permanent magnet, horseshoe, and the other is you pass the current and magnetize the circuit. Is it correct? So let us see motors. I again repeat, what is the principle of motor? It converts electrical energy into mechanical energy. The construction of motor, the similar construction of generator as it is of the motor. What happens? There is a horseshoe magnet, north and south. Why we take horseshoe magnet? So that there is a space where I can keep the wire. Yeah, I take a rectangular or a circular coil. बहुत सारा wire is wound. There is a number of turns in the wire, because as you increase the number of turns, the magnetism increases. As you increase the current, the magnetism increases. Moreover, in this coil, you can keep inside a iron core. Iron का piece रखिए, उससे strong magnetism develop होगा. Now this iron core has to be what? Has to be laminated. उसको टुकड़े में रखिए, नहीं तो वहां पे एडी करंट लॉसेस आएंगे, हीट जनरेट ज्यादा होगा. और क्या करिए? सॉफ्ट आयरन कोर रखिए, मैग्नेटिक लॉसेस कम होंगे. सो देयर आर वेरियस टाइप्स ऑफ लॉसेस कनेक्टेड टू अ इलेक्ट्रोमैग्नेट और थ्रू अ कॉइल. वन इज एडी करंट लॉस. व्हाट इज दैट? हीट इज जनरेटेड. तो हम उसको लैमिनेट करके तोड़ के पतला एंड देन वी कीप सो दैट नो करंट इज पास्ड इन दैट सर्किट. कोई लूप्स नहीं बन जाते. सेकंड इज सॉफ्ट आयरन कोर लेंगे, ताकि वहां पे मैग्नेटिज्म चेंज जल्दी होगा, वहां पे मैग्नेटिक लॉसेस नहीं होंगे. कमिंग बैक टू a motor works on the principle of Fleming's left hand rule. What is Fleming's left hand rule? FMI, mutually perpendicular, the thumb, the index finger and the middle finger. FMI means the force, the magnetism and the current. Now as you know, you have a permanent magnet, you have this. The current you will pass, you have this. The force will be generated in the coil, in the wire. So let us use the Fleming's left hand rule to understand the working of a motor which is placed on the board. This is north south. I see the direction of the current is like this. What will happen? How will the coil move? We will use Fleming's left hand rule. Before that, this is a commutator section. where you have carbon brushes. This is called slip ring section, wherein as soon as the coil rotate, the rings will slip. They will slip to different, opposite ends. So this is called slipping, so that it rotates smoothly. This is the axle of the coil through which the axis it will rotate. Okay, let us see Fleming's left hand rule. First of all, we will take AB section. Can you see this AB section? The current is coming out towards you, north south. Please understand, this will be the north and this will be the south in the Fleming's left hand rule. Don't forget, north south. This is the direction of the current. You will be asked to show the direction of motion of the coil, upward or downward. So please note once again, this is north, this is south, and this is the direction of the current in my coil, right? So current बाहर आ रहा है, north south ऐसा है. Where will this AB move? Upward. Can you see the direction of this thumb? Upward. So AB will move upward. I'll take example of this book. This is a coil with me, and now this is moving upward. As soon as it moves up, comes to this position, the slip rings will split, slip, they will turn, and here no current will be passed. Due to inertia, again it will fall. As soon as it falls, again the same thing will happen here. Correct? Current is constantly passing. This will again move, fall, again move, fall, again move, fall. Can you see the direction properly? Okay, let us know Fleming's left hand rule from this side. We will take CD ka side and let us use the Fleming's left hand rule. Where is the current going? Inwards, right? North south की तरह. So please understand one thing. Always use Fleming's left hand rule like this only. ठीक है? अभी हम लोग ऐसे यूज करते हैं, north south, right? अब current is going inwards. आपने बाहर साइड लिया है, तो ये वाले सेक्शन में क्या होएगा? उल्टा आएगा करंट, या फिर आप यही सेक्शन में लीजिए. If this is upwards, this has to be downwards. Now see how to apply this rule. Okay? अब आपका हाथ काट के तो नहीं रख सकते आप. That is not possible. So what you will do here? Okay? अगर मैं इसको ऐसे करता हूं, please see, it is not possible. Is it possible? नहीं. तो मैं क्या करूंगा? Okay, please see now. Can you see? The current is going inwards now. Current is going inwards and north south का direction उल्टा है. उल्टा है means ये जो direction है उसका उल्टा direction में ये coil move करेगा. So if this coil is moving up, this has to move down. Fleming's left hand rule apply करना आना चाहिए. You cannot take like this. No, this is not correct. It has to be mutually perpendicular to each other. So please utilize or apply the rule properly. So from north to south, always take the direction from north to south. And again मैं बता रहा हूं आपको hint. नॉर्थ से साउथ का डायरेक्शन लीजिए, नॉर्थ साउथ. करंट अगर बाहर आ रहा है, प्लीज सी विच इज करेक्ट, तो कॉइल विल मूव अपवर्ड. करंट अगर बाहर की जगह अंदर जा रहा है, तो उल्टा विल बी द आंसर, द कॉइल विल मूव डाउन. थैंक यू सो मच.